Time value of money. When a transaction occurs over a long period of time, there is a dimension added to the value of the transaction because the value of the dollar changes over time. The time value of money. An amount invested today will grow to a larger amount in the future. Accounting for items such as leases, bonds, pension obligations, loans, accounts receivable, and notes payable incorporate the need to understand the time value of money. Simple versus compound interest. Simple interest. Interest accumulates on the initial investment only. So in other words, a $2,000 investment earning 10% interest will accumulate $200 of interest each period. Compound interest. The interest accumulates on the initial investment and the interest earned as long as it remains in the investment. So let's see how this works. In the first period, the $2,000 investment earns $200. In the second period, there is now an investment of $2,200 comprised of both the initial investment of $2,000 plus the interest earned in the first year of $200. Now the interest will be paid on $2,200 at 10% interest, or $220. Several concepts are involved when we think about the time value of money. We're going to be looking at the time value associated with the single amount of dollar value, a single amount, and we're also going to be looking at the time value of money with respect to annuities. So let's understand what we mean by the difference between these two. The future value of a dollar. The amount of money that a dollar will grow to at some point in the future. In other words, what will my investment be worth in the future? The present value of a dollar for a single amount. The amount of money today that is equivalent to amount to be received or to be paid in the future. If a lender will receive $20,000 at the end of a 2-year loan, what is the value of the dollar today? Or what will you invest today to receive a certain amount in the future? This is contrasted to an annuity, which is a series of investments or payments, such as a loan with money payments, bond payments, etc., over a period of time. Now there's two types of annuities. One is an ordinary annuity, which is a series of payments made at the end of each period in the series. So made at the end of each period in the series. We're going to contrast that to annuities due, which are a series of payments made at the beginning of each period in the series. We'll also be looking at future value and present value for each of these. So the future value of an ordinary annuity. The future value of a series of equal-sized payments, with the first payment taking place at the end of a compounding period. What will my investment be worth in the future? Compare that to the future value of an annuity due. It's the future value of a series, again, of equal-sized payments, with the first payment taking place at the beginning of the annuity. Again, what will my investment be worth in the future? Now let's look at the present value. The present value of an ordinary annuity is the present value of a series of equal-sized payments, with the first payment taking place at the end of the compounding period. If an annuity will yield an amount in the future, what is today's value? And let's look at it for the present value of an annuity due. It's the same thing, except for the first payment takes place at the beginning of the annuity. So if an annuity will yield an amount in the future, what is today's value? So let's look at the future value single amount. Bill O'Brien would like to take his wife Mary on a trip 3 years from now to Europe to celebrate their 40th anniversary. He has just received a $20,000 inheritance from his uncle and intends to invest it for the trip. Bill estimates the trip will cost $23,500 and believes he can earn 5% interest. Well, good luck with that, Bill, because they're not paying 5% these days. So the interest is compounded annually on his investment. What will he be able to pay? Will he be able to pay for the trip with the accumulated investment amount? So this is the future value of 1, where n equals the periods and I equals the interest rate. Now, the solution in Excel is to take the rate, which is the periodic rate, which is the annual interest rate of 5%, the number of periods, in this instance it's years, which are 3 years, and the present value, which is the investment. He's going to be paying out $20,000. Now the formula in Excel, and make sure to use the @ symbol, is at future value is equal to the rate, comma, the number of periods, comma, the payment, comma, and the present value. Note the formula calls for a payment, but none is needed, so this value is 0. So the formula will look like this as you input it into Excel. It will be referencing cell number C1, then C2, the number 0, and then C3, and this will be the answer. There's not enough after he's invested that to have the $23,500 he wants. Now, let's look at another problem. When we look at the future value of the single amount, what a rate of interest should Bill look for? So we have a little bit different set of facts here. Same thing, they're going to go in 3 years to celebrate their 40th anniversary. He also received the same $20,000 inheritance from his uncle, but now he estimates the trip will cost him $26,600, and he will need what rate of interest compounded annually on his investment to earn $26,500. Future value of 1, n equals the number of periods, I the interest rate. The solution in Excel is 3 periods or 3 years. Amount of the present value to be invested is $20,000, and amount that he would like to have at the end of 3 years, or the future value, is $26,600. So now our formula changes. It is at rate, numbers of periods, payment, present value, future value. Note the formula calls for a payment, but it is 0, so put 0 in the formula. So the rate is equal to C1, the value in cell C1, the 0 value, C2, which is $20,000, and C3, which is the $26,600, and it will yield an answer of 10%. Next, we want to look at the present value of a single amount. So John has an investment opportunity that promises to pay him $16,000 in 4 years. He could earn a 6% annual return by investing his money elsewhere. What is the maximum amount he'd be willing to invest in this opportunity? Well, really what they're asking is, what will John invest today to receive $16,000 in the future? So we're talking about what would be the present value. So here we have the interest rate, the number of periods, and the future value. So what will the initial investment be? So the $16,000 is what he's going to get in the future. So the formula is, and remember in Excel to put in the @ sign, at present value, rate, number of periods, payment, future value. Payment is 0, so it's present value, cell C1, cell C2, which is 4, the 0, and then cell C3, which is the $16,000, and this will be the answer. Next, the future value of an ordinary annuity. So this will be a series of payments. So Leslie McCormack is in the spring quarter of her first freshman year of college. She and her friends are already planning a trip to Europe after graduation in a little over 3 years. Leslie would like to contribute to a savings account over the next 3 years in order to accumulate enough money to take the trip, assuming an interest rate of 4% compounded quarterly. Now this is going to be a different dynamic because all the other ones we've looked at were annual. How much will she accumulate in 3 years by depositing $500 at the end? So we're talking about an ordinary annuity of the next 12 quarters, right? So that's 3 years, 4 quarters for each year, beginning 3 months from now. So this is the future value of an annuity. N equals the periods, I equals the interest rate. So here it is in Excel. The rate will be 1%. Since compounded quarterly, you must divide the 4% annual interest by 4 to represent the 4 quarters in the year. Now our number of periods, the NPER. This will be 12. Since compounded quarterly, you must multiply the years by 4 to represent the quarters in a year. The fixed payment each period, the payment is $500, so she's going to be paying out $500. The present value, this is 0 at the beginning of the investment. Now we're going to be looking at annuity, so now we have to add in the type. So if it's an ordinary annuity which pays at the end of the period, the type will be the value associated with this cell will be 0. If it is an annuity due, it's at the beginning of the period and the type will be 1. So we put the value of 1 in this cell. So the formula is future value, rate, number of periods, payment, present value, type. So C1, C2, C3, C4, C5, and this is our answer. So now we have the same set of facts, but now she's going to be paying out the $500 at the beginning. So this is an annuity due. So we have the same information filled out as before. However, in C5, we'll be putting in the value of 1 in order to calculate this. And this makes more sense. She's going to have more savings because she's putting in the $500 at the beginning of the month, the beginning of the quarter as opposed to the end of the quarter. So it will be accumulating more interest. So now let's look at the present value of an ordinary annuity. So the mining company has borrowed money from a local bank. The note of the company signed requires 5 annual installment payments of $10,000 beginning 1 year from today. So again, at the end, so it's an ordinary annuity. The interest rate on the note is 7%. What amount did they borrow? Well, this is an illogical question because in the real world you would know how much they borrowed, but they're trying to get you to look at this from a variety of angles. And so here is the formula that we're going to be using. We're going to be using the present value formula because we want to know what's the present value of this annuity. So here we have the annual interest rate. And this is an annual calculation. Number of periods is 5. They're going to be paying out payments of $10,000 each period. The future value is 0. The type, this is the value of this is going to be 0 since it's an ordinary annuity. So it's going to be present value, rate, number of periods, payment, future value, type. And so this will be our answer. Now they're doing the same thing, but now this is at the beginning of the period, so everything stays the same except for we're going to change our type because this is an annuity due and it's at the beginning, so we'll change our type to the value of 1. Next, what should be the installment payment? So Toyota borrowed $100,000 from the local bank. The loan requires them to pay 10 equal installment payments beginning 1 year from today. So this is going to be ordinary annuity because it's 1 year from today. Assuming an interest rate of 8%, what is the amount of each annual installment payment? Again, you would know this, but they're trying to get you to look at the time value of money from bunch of different perspectives. So here we have our rate. The number of periods, this is annual. The present value is going to be $100,000, so that's what they're borrowing. The future value, it's going to be 0. The type is 0 since it's at the end. So here's our formula. Payment is equal to rate, so there's different formula. Payment is equal to rate, number of periods, present value, future value, and type. And this is our answer. So let's look at something a little bit more complicated, the original price of a bond. Again, you would know this information, but they're trying to help you understand more of the aspects of time value of money. So on December 31st, 2016, $100 million worth of bonds were issued at 6%, which is the stated rate. The bonds mature on December 31st, 2046, which means if it were issued on the 6th, 2016, they're going to mature in 2046. We're talking 30-year bonds. Interest is payable annually on each December 31st, but that's not going to begin to 2017, so we're talking about an ordinary annuity. We want to determine the price of the bonds on December 31st when it was initially sold if the market rate of interest for similar bonds was selling at 7%. Now remember, when bonds are selling, other bonds in the market are selling for 7%, and we're issuing bonds that are giving out 6%, this means that the bond is going to sell at a discount because people could spend the same amount of money and get 7%, so this is going to sell for less in the market since it's paying less. So we want to look at two streams of income. We want to look at the value of the interest payments over time, and we also want to look at the value of the bonds at the beginning of the initial issuance of the bonds. So first, we want to calculate the present value of the payment of the interest on the $100 million bond at 6% per year. But the interest rate on the date of the sale was 7%. We're talking about an ordinary annuity because this is going to be a stream of payments over time. So the annual interest rate that was available at the time that the bonds were issued and would have influenced the value of this, the present value of this future stream of money, was 7%. The number of periods is 30 years, so our payments are going to be $6 million per year, which is $100 million times 6%, or $6 million. Future value, presently this is 0, and our type, since we're talking about an ordinary annuity for the stream of payments, it's going to be 0. So present value, rate, number of periods, payment, future value, type. This is our answer. Secondly, we want to look at the present value of a single amount, which is what the bonds were issued, the value, the face value of the bonds at $100 million. So this is not the interest stream calculation. This is the other component of the bond, because at the end of the 30 years, they're going to be giving back the bondholders $100 million plus all of the interest they earned every year for 30 years. So the calculation of the present value of the $100 million bond issued when the rate was 7%, this is a calculation of the present value of a single amount. So the market rate was 7%, number of periods that the bond is going to remain outstanding is 30 years. There are no payments associated with this calculation. We just want to look at the present value of the $100 million. So this $100 million, we want to look at its present value because it'll be worth $100 million in 30 years. So what's it worth when they initially issued it on December 31st, 2016? And so since this is the present value of the amount at the beginning of the period when they initially issued it, it's going to be 1 because it's the beginning of the period. So here we have the formula: present value, rate, number of periods, payment, future value, and type. So notice what's different between these. This one is regarding the interest payments. This is regarding the future value of the $100 million. This is at the interest payments are at the end of the period. This is looking at the single amount at the beginning of a period. So this is our answer with respect to how much the bond itself was worth. Now we want to add the two components together, the interest value plus the bond value. So this is the total value and what the bond would have sold for on December 31st, 2016.